So in this video, we're going to talk about pointers, and specifically, we're going to talk about how pointers work differently with different data types. So we'll start out with a variable we call num1. We'll set that equal to an integer 11, and then we'll create a second variable called num2, and we'll set that to be equal to num1. So when we do this, we're creating an integer 11 somewhere in memory, and then we point the variable num1 at that integer. But the question is, what happens when we set num2 to be equal to num1? Are we creating a separate number 11 that num2 points to, or does num2 point to the same number 11 in memory that num1 is pointing to? So to test this out, let's flip over to VS Code. So there is our num1 equal to 11 and our num2 equal to num1 up here. And then we're going to print out the values of num1 and num2 here. But it's these two lines here that we're really interested in. This is going to give us the address where num1 and num2 are stored. So I'll run this. And you can see here that num1 and num2 point to the exact same address. They are pointing to the same number 11 in memory. So now let's flip back. So now the next question is, what happens if we set num2 to be equal to 22? Does this 22 overwrite the 11? And if this is the case, then num1 and num2 would now be pointing at 22. Or do we create a separate integer somewhere else in memory and have num2 point to that integer? So now to test this out, let's go back to VS Code. So this is the code we just looked at in VS Code, but now I'm going to add a few lines, and I'll paste this in. So this is where we set num2 to be equal to 22. And then with these lines, we'll show what num1 is equal to and num2 is equal to. And then down here, we'll show the addresses that num1 and num2 point to. So I'll run this. So this up here is what we had printed out before. And then this is after num2 has been updated. In other words, after this line of code over here. And you can see that num1 and num2 are now two different values, and that num1 here after the change is the same as it was before the change. So now let's flip back. So this diagram here is a representation of how it works. And the reason for that is that integers are what are called immutable, which means they cannot be changed. Once you put a number 11 into a particular place in memory, you cannot change that number 11. Now, you can point num1 to a different integer that is stored somewhere else, but you can't actually change the number 11 once you create it. So now let's look at another data type that works in a different way than integers do. I'm going to create a dictionary called dictionary1. I'm going to set it equal to value 11. So this variable is going to point at this dictionary in memory. Now, if we create another dictionary that we call dictionary2 and we set this equal to dictionary1, the question is, do we create an additional dictionary that is identical someplace else in memory and have dictionary2 point at it? Or do we have dictionary2 point at the same dictionary in memory? So the answer to that is they are both going to point to the same dictionary. So this is something that is going to be the same as if we are working with an integer. But what if we say dictionary2 value is equal to 22? Do we take that 11 and overwrite it like this? Or do we create a second dictionary and have dictionary2 point at that? So now to test this out, let's flip back to VS Code. So that's where we create dictionary1 with a value of 11 and then set dictionary2 to be equal to dictionary1. And then we'll print out dictionary 1 and 2, and this is where we look at the address where dictionary 1 and dictionary 2 are stored. So I'll run this, and you can see that dictionary 1 and dictionary 2 are both pointing to the same address in memory. So now I'm going to add a few lines of code here, and this is where we change the value in dictionary 2 to be equal to 22. And then we're going to print out the values of both dictionary 1 and dictionary 2 again, and then print out the addresses for both. So I'll run this. So now, after the value is updated, both dictionary 1 and dictionary 2 have value 22. They are the same. This is different than what we had with integers. Also, you can see that dictionary 1 and dictionary 2 are still pointing to the same address, which is identical to what it was before we did the update. So now let's flip back and talk about this. So with dictionaries, we can take that number 11 and then change it to a 22. Where integers are immutable and can't be changed, dictionaries can be changed. So dictionary 1 and dictionary 2 continue pointing to the same place, but we are able to change the value. So why is this important for a data structures and algorithms course? Well, the reason for that is we're going to see this concept come up a lot. For example, when we have a linked list, the nodes in a linked list are going to operate very much like a dictionary. So if you have two variables that point at the same node, you can change the value of that node. Say we change this from a 22 to a 44, say. The variables continue to point at the same node even though we changed the value. So I'm going to change this back to a 22, and I'm going to change this back to a dictionary and show a couple of other concepts. Let's say we have another dictionary that we call dictionary 3, and this one is value 33. If we set dictionary 2 to be equal to dictionary 3, we can take that and point that down at the new dictionary. So we can change where these variables point to. So this is something that you'll see quite a bit in the next section on linked lists. We might want to move head to point to a new node. And when we do that, we just need to set head to be equal to something else that is pointing at that node. And then there's another concept I want to explain. And to do that, I'm going to set dictionary 1 to be equal to dictionary 2. And of course, that's going to point that down here. And we'll have all three variables pointing at this same dictionary. Now the question is, what happens to this dictionary? Because we no longer have anything pointing to it. And if you don't have a variable that's pointing to this, you don't have any way to access this. So what Python does in this situation is Python will remove this through a process called garbage collection. And that is our overview of pointers.